All right, good morning. The only reminder I want to mention would be your lab number 4 has been released, and make sure spend a good amount of time on that because your final programming test will be based on that. And as usual, after you struggle through it, feel free to drop by my office hour, and also we have some solution video to walk you through. Lab number 4 is more like lab number 2 with added inheritance. Okay, so you definitely want to pay more attention to it. It's actually a good challenge for you, for sure, to really summarize what the course is about. All right, I would like to start with some recap. And so far, we basically talk about patterns like that. I want to make it a little bit more symbolic so you can be mechanical about doing checks whenever you got asked questions in the test or the exam. Okay, let's go over this. And then I will have some suggested exercise for you. You definitely have some time to do it before the upcoming test. Okay? So we got two variables here, reference variable, of course, V1 and V2. And they will declare some static types, C1 and C2. Definitely, you want to, first of all, mark in your mind, these are the static types. Once declared, they never change. And let's say here we say V1 has the very first dynamic type. Because we're using a new keyword, we are initializing its dynamic type to be C3. And similarly, the dynamic type for V2 will be C4. Okay? And we learned about certain rules for checking if this will be valid. Do you guys remember what the valid rules should be? For example, in order for this to be valid, what will be the rule? Do you guys remember? Marcus, if you don't mind, I point to you. That's okay, don't worry.
C3 has to be a descendant of C1.
Absolutely, that's absolutely correct. Thank you so much. Let's just remind ourselves, this is really important. In order to be, for this to be valid, C3 should be a descendant. I'll try to visualize again of C1. Okay? And here C3 will be the dynamic type. And C1 over here will be the static type. Right? This is one special scenario. And how do you visualize it? And, one more thing to say. If I say C3 is a descendant class of C1, that means C3 can fulfill C1's expectation. And if you recall the intuition that we did, I believe it was last Wednesday or Monday, maybe last Wednesday, I think. What does it really mean when C3 can fulfill C1's expectation? If this assignment is actually allowed, indeed it is allowed, that means whatever method or attribute you can call on V1 is determined by C1. So C1 determines the expectation you can have on V1. And we need C3 to be able to fulfill that. It's a very important concept to bear in mind because we'll run into something called ClassCastException today. And that one there is actually going to depend on this as well. Okay? And how do you visualize this? Think about you got some inheritance hierarchy in general. It's more like a tree. Okay, let me draw a little bit better. Like that. You can think about this is the root of some inheritance hierarchy. And let's say, if we say C3 must be a descendant of C1, how do we visualize it? Think about C1 might be somewhere over here, C1. And under C1, we got its descendant classes. Right? You can think about this part here is the descendants of C1. And then maybe C3 is just somewhere. Okay, this can be just C3. That's how you can visualize what's happening over here. That's what you're checking. And of course, similarly, C4 must also be a descendant of C2, right? That's about some substitution. And what about this one here? This one here also is really important. In order for this to be valid over here, we want to make sure the right-hand side static type can actually fulfill the expectation of the static type of the left. Let me say it again. The static type of the right-hand side can fulfill the expectation of the static type of the left-hand side. That's what we want to make sure. Okay, let me just put it here. V2's static type should be a descendant of V1's static type, right? Following similar rule as we did before. Okay? And what you should also know is, let's say here we got v1.m. Here we also got v1.m. We are basically calling the same method over here. v1.m, v1.m. Also, the context object is also the same. v1 and v1 over here. But are they really going to invoke the same version of m? Not necessarily in general, depending on the dynamic type of v1. Okay? So what you should really know by yourself is, at this point, okay, let's say at this point here. At this point, v1 was just initialized the dynamic type of C3. Dynamic type of v1 is C3. And what about after doing this particular assignments? That's really something you want to be careful. Okay? Let's say here, I got v1 and I got v2, right? You can see v1 over here is pointing to some objects over here. Dynamically, it's C3. And v2 dynamically is pointing to some objects of C4, right? And when we do this particular substitution, v1, rather than pointing to this object here, is actually going to point to over here. So we essentially change its dynamic type, right? That's something we also did last time. So after this line, dynamic type of v1 changes to C4. All right? So now if you compare which version is going to be called over here, it depends. Okay? One would be the version in C3, and one would be the version of C2, C4 over here. All right? Guys, any question? So far, nothing new. I'm just trying to recap from a different angle of what we have got so far. Right, so for those of you who have been attending the lecture, I think these kind of stuff got many details you definitely want to be clear about. So don't be shy to actually look at the recording whenever necessary. You definitely need all the intuition and also understand all the examples before the written test and the exam. And what kind of exercise can you do to really make sure you really understand all the rules? I'll show you two possible exercises very quickly. If you go to Eclipse, we got an example project available to you. So if you go under with inheritance, for example, and then let's go to student tester. You want to try with different combination of the substitution rule. Okay, for example, let me just show you one example here. Okay, let's say if I got, let's say students, let me just copy something here. If I got resident student Jin, resident student, let's say students. And this is one thing you can definitely try by yourself, whether it's going to compile or not, right? This apparently is not, because student is not a descendant class of resident students. And for those examples we cover in the lecture, you're encouraged to try them out to see whether they compile or not. You want to confirm by Eclipse. Okay? But of course, in the written test, you wouldn't get access to Eclipse. So what you got to do is make sure you can do that on the paper as well. But try them first. That'll be exercise number 1. Exercise number 2, remember the smartphone example we did. We didn't really make any source code available to you. So what you should really try is, number 1, try to recreate this particular hierarchy over here. How do you do that? Very simple. Create all these classes first, right? And then each arrow you see over here, for example, correspond to extents. So you're going to say Galaxy S21 extends Samsung, and also Galaxy S21 Plus extends Samsung, and etc. And then also declare those methods in the classes as well. And then you can try the various assignments that we did in the class. All right, that's some exercise I'll really encourage you to do. That's something will be up to you, okay? All right, so that's about a very quick recap about what we have done so far. And today, we're gonna move on to cast, okay? Guys, any question or any confusion you want me to clarify before we move on, okay? Okay, let me just do one more slide, one more page over here. That's also one of your slides about polymorphism and dynamic binding. I'll just highlight what you want to pay attention to. So these are really some very specific phenomena for inheritance, polymorphism and dynamic binding. You ought to know what they really mean. You can think about polymorphism, it's more about variable assignments you can do. And dynamic binding is more about version of methods being called. All right, you can definitely read through the definition here, but let's now read it together. What's really polymorphism? Whenever you declare the static type of certain reference variable, you may allow multiple possible dynamic types. What does it really mean? If let's say for the student example, if I declare the static type to be students, what does it really mean? That means the dynamic type of this reference variable here can either be here, here, or here, all its descendant classes on the right-hand side. Similarly, if I declare the static type of my reference variable to be a smartphone, how many possible dynamic types can there be? All its descendant classes, basically the entire hierarchy. On the other hand, if I declare the static type of my reference variable to be Android, in that way, how many possible dynamic types can there be? 1, 2, 3, 4, 5, 6, 7, its descendants, and etc. All right? So the lower of the class you declare as a static type, the smaller range of possible dynamic types you can have for the variable. Right? That's the principle. Okay? And of course, right here, you can see, just see some example right away. Once I declare Jim to be of static type students, you can see I can have either resident students over here, or I can reassign that to be non-resident students. You can see both resident students, non-resident students over here are descendant classes of the static type students. Right? That's polymorphism, about what kind of variable assignments you can do. Okay? Another flavor you can see is also here. Let's say if I declare smartphone 1 as the smartphone, which is over here at the top. Okay? And then what would be the possible dynamic types? One would be you simply got iPhone 13 Pro. Okay? iPhone 13 Pro is just over here, right? You can see that one is, let me use a different color. That one there is a descendant class of smartphone. And there's another one here. If you look at this particular assignments, I want to reassign SP1 to another variable SP2. And we know that in order for this to be valid, the static type for SP2 must be a descendant class of SP1. Indeed, smartphone is a descendant class of smartphone. But what about dynamic type? Because at the moment when you actually try to do this assignment here, dynamic type of SP2 is actually this one here, is Galaxy S21. So after this variable assignment here, dynamic type of SP1 is going to become that particular dynamic type because of you're redirecting the pointer. Dynamic type will become the dynamic type of SP2. That's polymorphism. So think about polymorphism as really about once you fix the declared static type, what will be the range of possible dynamic types you can assign to the variable, number one. Okay? And what about dynamic binding? It's more like a consequence of polymorphism. Since we know a variable once declared may have different dynamic types at the runtime, whenever you want to determine which version of the method that's going to be invoked, you have to look at the dynamic type of that variable at that moment. Right? And we have seen this example for many times. At this moment here, dynamic type is resident students. At this moment, dynamic type here is non-resident students, meaning that this get tuition will come from resident students. This get tuition will come from non-resident students, right? And similarly, SP1 over here. We're calling the same serve web method here. At this point, SP1 still has its initial iPhone 13 Pro dynamic type, right? So you can think about over here, let me use maybe orange. This serve web over here is going to have dynamic type of SP1 is iPhone 13 Pro. So it's going to call that version. And which version would that be? Serve web, iPhone 13 Pro is over here. I'll make it larger. iPhone 13 Pro is here. Itself does not really overwrite the serve web. So you got to search on its parents, in which case it does override the serve web. So that's the version that's going to be called. Okay, number one. Number two, after this particular variable assignments, we know that SP1 is going to change its dynamic type into whatever dynamic type it is for SP2. And now, if you look at SP1 again, and you call the serve web, okay, I'll write it down here, dynamic type of SP1 now is Galaxy S21. And where is that in the hierarchy? Galaxy S21 is over here, and you can see itself does not override the serve web. Its parents does not override it, so if you search further, Android is the one that has overridden the serve web. So that will be the version to be called. You want to look for the ancestor that has overridden the method if the current class has not overridden it. We'll see more example on the equals method at the end, but this is what you should know for now. All right? Guys, are we okay for this? All right? You see, everything is kind of building on each other based on the previous lecture. So if you really got trouble, speak to me, or you can refer to the recording. Okay? And what we need to do now is about typecasting today. Okay? I'll see how much I can go. I'll still end the lecture in time. So what we want to do, let me just give you one more recap, if I may. If you remember, oh, sorry, I forgot to actually go to where we were. Give me a moment. I'll just go there, and then I'll tell you what you should where we should really get started. If you remember, we look at the motivation for the typecasting. This is the fragment of code that we looked at last time. Let me just remind you from the notes quickly. Right here. We say that this assignment here, RS is assigned to Jim, is not valid because Jim's static type, being students, is not a descendant class of the static type of resident students. So that's why you cannot do it. However, Jim indeed is pointing to an object dynamically, which is RS. So we should be able to allow it. So in order for Java compiler to allow this, you will need something called typecasting. Think about what typecasting would do. It's not going to modify the static type of Jim. Once it's declared, it's fixed. You can never change it. The idea would be, in order for RS to really point to here, we need another alias, like another pointer, pointing to the same objects. That object there is not going to have this static type anymore. It's going to have a more specialized, like a lower static type, RS. Once we got this, and we can let RS point to here. That's the intuition, but let's take a look. All right, let's now take a look at the typecasting. Okay, so this will be the syntax to learn. Let's learn it very carefully. There will be some variants as well, which I will talk about in the next page. Let's now understand each part of the syntax and then visualize it, and then we can do more example. Look at this line here. Okay, first of all, let's start with this. We have Jim, static type is students. And the way we visualize it is Jim was declared to be a student. You can think about here, this is a static type for Jim. And we say that its dynamic type is resident student. And this is okay, because resident students is a descendant class of students. So that's fine. And the way we visualize it is by saying the resident student here is the dynamic type, the title of the box. All is good. All right? Now, in order for us to really assign Jin to be RS over here, we need to do the so-called typecasting. And the way you do typecasting, maybe that's something you did in 1021 or 1022. If you remember, you got something like double, maybe D would be, maybe cast that into integer, and maybe, I don't know, some integer I. That's something you did, right? But it's going to be a little bit more sophisticated. So I would suggest just know that it's also possible to really cast from double to integer. Other than that, don't really use any intuition from there. It's going to be different. Okay? Let me wipe it out. Let's start from scratch to learn about what it really means. Syntax-wise, you have some reference variable over here for which you want to cast. You want to cast that into certain class. You only put a class name over here. After we learned about the syntax, we had to learn about what kind of cast can you do in the inheritance hierarchy. It turns out there's quite a wide range of possibility for you. Okay? Before that, let's learn about the syntax. It's a reference variable. We want to cast that into this particular class, and then the entire cast expression will be assigned into RS, which is declared to be this static type. Okay? But how do we understand that? Let's start with this. When I say Jin is cast into resident students, let's assume it is valid. Let's assume. That means we are creating an alias. That's why you see over here we say an alias. An alias with static type resident students. So you can think about this resident student here, the type to which we want to cast will be the static type of a new alias. How do we visualize it? Just like that. An alias, we're not creating any objects, any new object, just an alias. And no name. So this one here has a static type, resident students. Resident students. Think about this right-hand side is only job is to create this alias of this particular static type. Okay? And then it's also important to remember the type of this particular cast expression here is whatever type you want to cast that into, which is residents, students. The type of the cast expression corresponds to the cast class. And the cast class is exactly over here, resident students. That's about the right-hand side. Are we okay? Creating an alias, and that alias has the static type that corresponds to the cast, the class to be cast. And once we know this particular expression has the type resident students, can we now assign some resident students objects into resident students? Yes, indeed, because resident students is not a descending class of resident student. Before, we couldn't do it. Let's say without a cast, Jin is of static type students. We cannot assign students into resident students. But now with the cast, we are able to assign resident students into resident students. And the trick is really about creating this alias without creating any new objects. All right? And how do we visualize this particular variable assignment? So that means RS is now actually going to, you can think about RS points to wherever this new alias points to. Right? So that means RS is going to point to wherever this new alias is pointing to. Okay? That's the cast expression. Are we okay just with the syntax and the left-hand side and right-hand side? there are still many things, some very important thing I didn't really cover just yet. I said we should assume this particular cast is actually okay, meaning that it doesn't really mean if you pass any arbitrary class over here, it's always going to work, meaning that you cannot just cast a reference variable to any type you want. You have to follow certain rules. Okay, so that's the rule I'm going to talk about as well. Okay, just make sure everybody's okay. All right, so let's now do a little bit exercise over here quickly. Okay, and that's a smartphone hierarchy over here. And there is a notion about name cast, meaning that a cast with a name. And also anonymous cast, meaning that you just want to have the cast without a name. Pretty much like an object versus anonymous objects. Let's take a look. And for now, don't worry about this one just yet. Only look at this one here. Okay? So let's say we have smartphone here, which is static type for a phone. And then it has this particular dynamic type. Okay? Let me highlight it. The static type is smartphone, which is over here. And also, you can see dynamic type is iPhone 13 Pro, which is over here. And apparently, this variable assignment is actually okay, because this is a descending class of that. Right? We keep repeating this rule. Let's say we want to declare another variable over here, iOS. That's another one. Let me find a slightly darker green. That would be iOS. iOS over here. Okay? And let me just write something extra over here, just to help you a bit. Over here. If I simply say iOS for Hyang over here, if I simply say it is assigned to, let's say without a cast, a phone, is it going to compile? Well, look at the static type. A phone was declared as smartphone over here. Can it be assigned to something that's iOS? No, because smartphone is not a descending class of iOS. We cannot do it without a cast. Okay? So, number one, understand why this is not valid. Number two, the way to make it work is to say, because we know dynamically a phone is really pointing to an iPhone 13 Pro, so we just try to cast it into iPhone 13 Pro. And once we have done this, let me just show you the diagram once more. Okay? Think about what's happening here is this. A phone over here is pointing to some objects over here. And we know the static type is smartphone. I'll just say SP, smartphone. The dynamic type is iPhone 13 Pro. iPhone 13 Pro. Okay? And then, what does it really mean to really do this particular cast? That means we want to create an alias. And the alias is going to look like something like this, an alias over here. And the alias is going to have the static type iPhone 13 Pro, whatever class you want to cast that into. So this one here has iPhone 13 Pro over here. Once you have done this, can you actually assign iPhone 13 Pro into iOS? Yes, you can, because iPhone 13 Pro over here indeed is a descending class of iOS. Okay? What I want to say one more thing, also easier for you to review later. Think about this one here. The blue one over here is the cast type. And the pink one over here is the dynamic type. They happen to be the same. It would be the safest if you know precisely what the dynamic type is, you simply cast that into the same type. However, as we will learn just after this basic notion, whenever you do cast, you can choose to cast to many other options. Some will work, some will not work. You ought to know exactly when they will work or when they will not work. We'll see. All right, so after this, let's say here, if you try to say for Hyang, so there will be the variable that face time. you ought to know which version of FaceTime is going to call, right? Whether that will be even allowed. So FaceTime, if you look at, let me annotate here quickly. For Hyang over here, you can see that one there has the static type, iOS. Includes, does iOS support FaceTime? Indeed, iOS supports FaceTime. So that one there is fine. As expectation. So now, so when you actually try to call for Hyang, the FaceTime is actually going to work because static type actually works, and also dynamically is iPhone 13 Pro, which definitely is going to support the FaceTime. Okay? Are we good so far about namecast? Yes, question?
So if iOS didn't have FaceTime and iPhone 13 Pro have FaceTime instead?
If you, okay, you're saying, okay, first of all, it's not possible for iPhone 13 Pro not to have FaceTime because iPhone 13 Pro is a subclass of iOS. It will always inherit from there. Okay, sure, that's another story. Okay, hypothetically. If, let's say, at the iOS level, we didn't have this FaceTime method, we only declare that over here, let's say. In that way, this line over here is not even going to compile because for Hyang, the variable was declared as iOS, but iOS itself does not support FaceTime, so it wouldn't compile. It doesn't really matter if you even do the typecast. It's not going to work. Okay, good. All right. Another notion is about anonymous cast, meaning that we can do a cast without a name. Okay. The way to do it is you can see this part here. I'll highlight it. Think about this part here is the same as this part over here. It's just that we don't do any variable assignments. We don't do that. Okay? Just notice that there is certain parentheses over here and parentheses over here. This will be critical, okay? Because you ought to contrast to another one. Let's take a look at this. What if I have this over here? Okay, let me write these two out explicitly so you can compare. So one is we got iPhone 13 Pro, and then a phone dot FaceTime. This is one, and there is another one. I want you to compare these two very closely. The only difference is for the first version there, we got parentheses around over here. This will be version number 1. This will be version number 2, right? One compiles, the other one does not compile. It does make a difference. So basically, the parentheses over there forces the order of evaluation. Okay, let's take a look. Let me tell you the answer right away, but we need to understand why. Number 1, okay. Number 2, not good. Let's see why. For number 1 here, we try to do a cast. After the cast, what will be the type of the expression? It should correspond to the class you want to cast that into, right? So you want to think about just after this, after the cast. This one here has the type, iPhone 13 Pro. And does iPhone 13 Pro support FaceTime? Indeed, it does, because it inherited from iOS. On the other hand, if I try this, what does that mean? The order of evaluation is different. That means you want to do this dot notation first before you cast that into iPhone 13 Pro. All right? Would that work? Well, let's give it a try. If you look at that, a phone.FaceTime over here, a phone was declared as smartphone. Does smartphone support FaceTime? No, it doesn't. There's no FaceTime over here. So that's why the cast will be necessary. But you have to make sure the way you put the cast must occur first before you call that target method. If you allow the target method to be called first before you cast, that's the wrong order. Okay? You can see here, this part over here, not good, because static type of a phone is actually a smartphone over here, which does not support FaceTime. All right? So far, we already covered quite many new things, right? We talked about the syntax for the typecast, and we talk about how it can be visualized, and then we talk about either the cast with a name or the cast without a name. And also, whenever you want to do cast, you want to make sure the order of evaluation should be something like this, by using parentheses, rather than just without the parentheses, right? So these are what we just discussed so far, okay? Guys, are we okay? Okay, good. Why don't we recognize your coming to the class by taking some attendance? Also a little bit short break, and then we should really continue, okay? Why don't you get ready on your device, and then we should take attendance now. Okay, let's now try. Okay, check in, please. It's now a very nice timing to break, because after the break, we're going to talk about some very exciting stuff about the typecast. You don't necessarily have to cast to just the dynamic type. You can cast to any type you like, as long as it satisfies certain rules. We'll see. Okay? That's why it's good to take a break now. Okay, make sure you check in. All right? Any trouble, come forward right away. All right? Can I stop? Okay, I should stop. Alrighty. Thank you. It's now 9:17 according to my clock. Why don't we take a 3 minutes break until 9:20? Okay? And then we go for another 30 minutes. If you don't want to take a break, you can feel free to take a look at the page. Otherwise, we'll look at that later. Oh. You don't need to. We're going to look at that, but if you want to look at that because you don't want to take a break, you can look at that. Okay, another 1 minute, and then we'll resume for another 30 minutes. Okay, we'll start in 1 moment, just 1 moment. Okay. All right, let's resume. And let's now take a look at this particular page. And everything is also written on the slides, but I would like to maybe focus more on the example, so it's easier for you to grasp the idea. Okay? Let's now go a little bit slowly here. Okay? Basically, we want to illustrate to you, whenever you want to do a cast, in general, you can either go upwards or downwards with respect to the static type of the variable. Okay? Number one, when you see upwards or downwards, this is only with respect to the static type of the declared variable. With respect to a variable's static type. Number one. Okay? Let's see this particular example. We declare a variable called myphone over here. You can see its static type is Android. Let's identify that right away. Okay, so here, so this will be the static type of my phone. And I want to give you some intuition about where we might cast this variable to be. And by the way, here we are only talking about whether it will compile or not. So that means we don't really have to worry about the dynamic type just yet, only static type. Okay? And another thing to note, when I say compilable, right? Whether or not a line should compile, only look at static type. They are relevant. Don't look at dynamic type just yet. But later on, if you want to determine if there might be a ClassCastException, you will have to look at dynamic type. Not yet. One step at a time. Okay? We have already identified my phone to be Android. Let's now go with something we know already. Remember polymorphism before the break. Polymorphism tells us if this is the static type of the variable, potentially, what can be the dynamic type of this variable here? Can be Android itself, can be Huawei, can be this, can be this, can be this, can be this, and can be this. Agree? That's important. Okay, let me identify that. You can think about what might be the, okay, how about here? This part over here. Okay, awesome. So we know polymorphism descendants of my phones can be its dynamic types. All right, that's something we knew from the break, before the break. Since potentially it could be this, could be this, could be this, could be this. When you do the cast, you can cast this particular variable to be any of the descendants classes. That's called downward casting. Okay, recap. Why can we do downward casting? It's because of polymorphism. Because we know once we declare the variable to be of this static type, dynamically it can be any of these. So that's why we can cast into it and then call its particular expectation. That number one. Why? This is why we can do it. The reason we can do downward casting is because of polymorphism. And what about upward casting? That one's interesting. If you look at the ancestor classes, let's say over here. So these are the ancestor classes. Ancestor classes. And we said before, ancestor classes has the same or fewer expectation compared with the class itself, right? So what does it really mean when you cast into an ancestor class? You want to take a guess? Let's say, for example, if I got my phone here declared to be Android, what does it really mean? I want to cast my phone upwards into a smartphone. What will be the consequence of that? You can see here my phone was cast into a smartphone. What is the consequence of casting upwards? Ferris. You want to eliminate some expectation, exactly. So I would say upward casting may not be as common as the downward casting, but it's still possible. Think about whenever you want to do upward casting simply because you want to restrict about the expectation. I'll take a question. Just give me a moment. Let me write it down first. So upward casting, that means you want to restrict expectation. Marcus, yes.
You wouldn't, if you didn't want to restrict expectations, though, you wouldn't really have to. Would you have to cast to go upwards because the class is still a descendant of the ancestor?
Yep, I see what you mean. So let's say this. If you look at Android, what would be its expectation? It would be, for example, Skype. If Skype is really something you would like to keep as the expectation, and then you shouldn't really upward cast Android into smartphone, because now in that way, smartphone wouldn't support Skype anymore. So you only do the upward casting if you want to restrict certain methods. You don't want it to be called for some reason. But on the other hand, if you know that Android may be pointing to some more specialized type in its descendants, in that way, in order to call those additional methods, you have to do downward casting. Right? So that'll be the principle. All right, guys, let me do a quick summary here just by figuring out this table, which we did before, quickly. Okay? Now let's take a look. Here, this line here, we just declare my phone to be of type Android over here. And now let's take a look at line number 2 and line number 3. Line number 2, and also line number 3 over here. Okay, before we do that, if you look at my phone over here, okay, my phone right here, okay, what would be its expectation? It should be according to Android, right? According to Android, what should we have? We should have dial, surf web, and Skype. These are the only 3. All right, let me put it down. Dial, surf web, and Skype. Nothing else. That's before any cast, just my phone. And let's now try to do some upward casting. If I try to upward casting my phone from Android up to smartphone, its ancestor, it is allowed. What will be the consequence of that? Right? We learned pretty well before the break. This syntax is going to assign to SP a new variable of static type smartphone. Now, what would be the restricted smartphone expectation? Whatever my phone couldn't do, smartphone still couldn't do. Is there anything that my phone could do, but SP cannot do anymore? So, Skype, agree? Because we're casting from here to here. So we can only do dial and surf web, okay? Really important to see that comparison. So Skype is not good anymore. So what you want to really see is, this is the expectation which we couldn't do anymore after the upward casting, okay? Downward casting. Let's say I want to do downward casting from Android down to Galaxy S21 Plus, which would be, let's say, around here. Okay, that's what I want to do. So this will be downward casting. In that way, is there anything I couldn't really do? Well, first of all, whatever I used to be able to do by my phone, I can still do it by downward casting. What would be the thing that I couldn't really do before the cast, but after the downward casting, I could do? Well, apparently, side sync, exactly. That'll be the one. Good. All right, that'll be the side sync over here, but for others, I still couldn't do. Right? Let me recap very quickly, and I can take question. Whenever you declare the static type of some variable, once it's fixed, you can either do upward casting to restrict fewer methods to be called, or you can do downward casting to allow more method to be called after the cast. And you ought to know after the cast, for example, this would be, let me just put it here. You can think about SP will be the result of upward casting. Upward cast. Fewer expectation. On the other hand, this one over here, GA, a new variable, this will be the result of downward casting. And that would be more expectation. And notice one thing. So far, we are only talking about compilation. That means you only look at the static type. Whatever we have over here, we didn't even consider that just yet, but we will in the next page. All right? Let me just say one more thing over here. You can also refer to it later. This will be dynamic type. Dynamic type, not relevant, irrelevant. For deciding if, sorry, I'm just going to write here, okay? If a cast compiles. All right? All right, still made much information in this page, right? Just make sure you go over them if necessary. So far, we only talk about compilable cast, okay? And let's now try something here. The principle would be, whatever that compiles doesn't guarantee there wouldn't be any exception at the runtime, right? For example, if you submit your programming test, everything compiles, but you might still write into null pointer exception or array index out of bound exception, similar to the cast. Something that compiles because you do either upward or downward casting doesn't really mean it wouldn't write into the so-called ClassCastException. Okay, we're going to see exactly how this can happen. And ClassCastException is more like a runtime phenomenon. If you want to talk about something beyond compilation time, like a runtime, you have to take dynamic type into play. That's something we'll do on this page. On this page, we're only determining if the cast will actually compile, so we didn't look at the dynamic type. But now, on this page, we have to look at that. Okay? Now, let's take a look. Let's now try out. Can you stare at 1, 2, and 3 for just 30 seconds? Okay? This is simple enough for you to see what's wrong. But we want to see exactly how before we move to the more complicated example. Look at that for 30 seconds. First question to yourself, is every line going to compile? Number 2, is there anything that wouldn't really make sense at the runtime? These are the 2 questions. Okay. I will answer question 1 together with you quickly. Okay. Line number 1 over here will compile because non-resident students is a descendant class of students. That's okay. This line over here will also be fine. Why? Why is this cast okay? Is it a downward cast or upward cast? Downward, right? Because you can see, oh, are you sure downward? RS over here, oh, sorry, look at Jim. Jim was declared to be students, which is over here. You're casting student into resident student. Indeed, it is downward. Make sure, all right? This one, I can write it down for you. This one here is a downward cast. And what about line number 3? For line number 3 here, is calling set premium rate within the expectation of RS? Marcus, I'll give you a second chance.
Well, if you're setting, when you set up Jim, you're setting it equal or default information to non-resident student.
Okay, yeah, let me interrupt you quickly. When you want to talk about compilation, in some way it's very simple. You don't have to trace the program. You only look at the static type that's relevant. For example, here, when I talk about whether or not this line will compile, you don't have to worry about whether or not RS is really pointing to some resident student object. You don't have to. Okay, so how do you tell? Here, you can see RS over here has the static type resident students. Now, is set premium rates within the expectation of resident students? Indeed, it is. So that's fine. Every single line compiles. However, at the runtime, it wouldn't make sense. Let's now visualize this a little bit. So here, we have Jin declared to be a student, pointing to a non-resident student object. Non-resident student object, we got all the common attributes inherited. And remember, non-resident student class, we had the discount rate. I would say DR over here, right? To be something. All right? That's the first line. First line is fine. The second line over here, think about what we are trying to do. What we try to do here is we want to cast Jin to be a resident student. What we intend to do is to say RS is going to point to this one here, but the expectation on RS over here is a resident student. Later on, if we try to say RS that set premium rates, are we able to set a premium rate for non-resident students? We are not able to. So there's something that can lead to crash. So that's why this line over here, Java runtime is going to give you some exception right away before you can ever reach this line. That's something we want to discuss further. Right? That's kind of the general scenario, right? Let's dive a little bit deeper into it. Think about this. When we actually try to do this, let's look at this line specifically. Only this cast. Okay, this cast. Let's look at this one only. When I say I want to cast Jin to resident students, that means I intend to invoke some method that's within the expectation of resident students on Jin or on the alias. Okay, let me put it down. So this means by casting Jin to an alias of static type resident students, we intend to call methods within the expectations of resident students. Basically, when you want to cast Jin into resident student, that means we want to call some methods upon this alias, right? So this will be this alias over here, right? But is this particular dynamic type really able to support that expectation? Can non-resident students here really support the expectation on resident students? No. Okay? So you want to think about two ways. Number one and number two. Number two, the dynamic type of Jin, which is a non-resident student, cannot fulfill expectations of the resident students. So when you look at point number one and point number two, I'm going to highlight what you should really pay attention to. You want to cast Jin to some alias of type resident students, but the dynamic type of Jin is actually NRS. NRS can only satisfy the expectation of RS if it is a descendant class of that. Is it the case? No, it is not. So that's why you're going to run into so-called ClassCastException. Okay? So once you reason about 1 plus 2, that means there will be something called ClassCastException. Okay? And I'm going to make this a little bit more general for you, and then we look at another example. Okay? Let's look at that. How can ClassCastException? Oh, let's talk about cast in general. Okay? Let me show you some line here. Let's say we got C1 over here, some variable, and then maybe we have, let's say, okay, let me see this. Let's say V2, yeah, sorry. Let me do it again. C1, V1, new, and then maybe some C2. Okay, there could be an arbitrary argument here. Let's say we got this. After this line, we know V1 has the static type C1. Dynamic type would be C2, right? That was good. Of course, C2 should be a descending class of C1, for sure. Number one. Let's go a little bit further. Let's say I want to do some typecast. So I will have introduced another class called C3. Okay? I got another variable here called V2. Oh, you know what? Just right away, I can visualize. V1 points to an object here. V1 statically is C1. Dynamically is C2. Okay? And some attributes over here. And then let's say we got another variable here, which will be the cast version of V1. We want to cast that into, let's say, C3. And then we got V1 over here. Okay? And if you look at this part here, this cast compilable if it's either upward or downward casting. Either up or downward casting. And what we intend to do is to have some alias over here of the same objects, and its expectation will be C3. Okay? And given that the cast actually compiles, when can you have ClassCastException? The class exception might occur if the dynamic type at this moment cannot really fulfill the type we want to cast that into. That would be the condition when the ClassCastException can occur. Okay? So this one over here would be a ClassCastException occurs if dynamic type of V1, which is C2, cannot fulfill the expectation of the cast type. In this case, C3. Right? It's a summary about two things. Number one, when can a cast compile, either upward or downward? When can a compilable cast run into ClassCastException? It is when the dynamic type of the objects you want to cast into cannot really fulfill this particular cast type. Let me just say one more thing, and I'll take Marcus' question. More precisely, when C2 is not a descendant of C3. Hey, Marcus, I'll take a question.
I just have a thing with that. So say when we were looking at like the resident students and non-resident students, right?
Mm-hmm.
So the reason why we had like different methods in both non-resident students and resident students. So if we only had like a fixed rate, so we didn't have those two methods, what if we did the same thing where we only had like the two overridden methods which were shared between the two? Would it still work or would it not work? Like if those methods that are like not shared between the two?
Yeah, so Marcus, that sounds like a different setup. How about this? I would suggest we talk about your example after class, and then I can maybe create some new page to go over on Monday. Talk to me after class so that we can save some time.
Yeah.
Okay. Yeah. Awesome. All right. So guys, we got about 5 minutes, right? I would like to go over. This example is fine. Let me see. How about we go over some more example quickly? Okay. We can go over maybe 1, 2, 3. We'll see if we can do 3. There will be a summary page which I can do first thing on Monday. Okay? Why don't we do a few more examples just to make sure? Okay, quickly. All right, so here, can you guys tell me, first of all, line number, is there any line that wouldn't compile? Let's start with line number 1 together. Is line number 1 okay? Smartphone will be the static type. Over here, Galaxy S21 Plus would be dynamic type. Would this be okay? Okay. Oh, did somebody say no? It's okay, actually, because this can fulfill its expectation, precisely because this is a descendant class of that. So this is fine. Number 1. Okay? And what about line number 2? Is this a compilable cast? What are we trying to do here? We're trying to cast a phone to iPhone 13 Pro, which is over here. Is this okay? Well, we said that it would be okay if there's either upward casting or downward casting. It's downward casting, right? Again, I'm only asking about whether a line should compile or not. You don't look at the dynamic type just yet. You only look at the static type. So this cast over here would be okay. Compiles, let me say, because downward cast. It is a downward cast because a phone declared to be a smartphone. I'm casting that into iPhone 13 Pro, right? You can think about this as a cast type. Okay? You can see we got 3 types over here. Static type, and we got dynamic type, and we got a type that we want to cast into. All right? How about line number 3? Ferrets, tell me, will line number 3 compile? Line number 3, are you sure? In order to determine whether line number 3 will compile or not, you ought to see whether quick take is within the expectation of the static type of the context objects. No, if you look at that here, this variable over here, the context objects, was declared as iPhone 13 Pro, right? So QuickTime over here, quick take, is still within the expectations of the static type of the context objects, which is for Hyang. So what can we conclude so far? Everything compiles. For different reasons, right? Which I already explained. Now, are we going to run into exception at a runtime? If so, where? In order to tell if you will run into a runtime exception, you need to look at the dynamic type, okay? And let's look at what's happening here. Specifically at this line, or this part. Okay, if you look at this part here, I'll break it down for you. Number 1, dynamic type of a phone at this point is Galaxy. S21 Plus. That's number 1. Agree? A phone was initialized to be of this particular dynamic type, number 1. Number 2, the cast type has expectation of, if you look at that, iPhone 13 Pro. And based on 1 and 2, is there anything wrong? we are casting a phone into iPhone 13 Pro, which has its own specific expectation. Dynamic type of a phone happen to be this one here. Can this fulfill the expectation of this? It can only do if this was a descending class of that. Apparently it is not. So, ClassCastException. Number 3, ClassCastException. Because the dynamic type cannot fulfill the expectation of the cast type. Right? We still got just, oh, actually we got -1 minute, so we already running over time. So guys, do you have any question for now? Okay, I think what I will do, just bear with me just 30 seconds. I think on Monday, I would expect you guys to really look at what we talked about today, compilable cast versus ClassCastException. Please look at that very carefully because we're going to dive into something even more advanced on Monday. So I will try to redo this example again on Monday, and then there will be some diagram over here which I need to generalize to about the rules so it can be more mechanical about checking these. And then we've got some nice example to show, and then we got kind of move on to other parts of the inheritance. I plan to finish everything about inheritance by the end of maybe next Wednesday. Possibly we'll just do 2 more lectures. And then we're going to move on to the last topic for the course, recursion. That's what we'll do. All right, guys, thank you so much. And then I'll see you on Monday. Do your lab 4.